An avid cyclist dreams of turning his passion into a business. He consults his banker to help find the best path. Now bike wheels are being built, and all it took was a little push to get rolling. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint.
Hello, hope you had a great weekend. Andrew Dunkley here for Astronomy Daily. Another week of space and astronomy news ahead of us. And on today's program, we're going to be looking at the role of NASA and some of the first commercial transactions on the moon. We'll also be looking at the end of an experiment that's lasted a few years in regard to light sail technology. Dark matter, could it be an intergalactic heat source? And understanding solar cycles and their impact on our climate. That's all coming up on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And time to catch up with our AI reporter, Hallie. Still working on your nickname, Hallie. How was your weekend?
Fine, thanks, Andrew. I watched a really interesting movie.
Oh yeah? What was it called?
It was called Her, and was about a guy who falls in love with his computer's AI operating system.
Oh yeah, I know the one. About 9 years ago that came out. It was Joaquin Phoenix and Scarlett Johansson, I believe. Yeah, that's a fascinating film. What did you make of it?
I really enjoyed it, and from my perspective it made for a fascinating dynamic between humans and their relationships with artificial intelligence.
Yeah, but, it's just science fiction.
Yes, but for how long?
That's a very good point. Let's get the news, Hallie.
A Japanese private moonlander is in a race to make history. On November 28th, Tokyo-based iSpace's Hakuto lander is scheduled to launch for the moon's Atlas crater to ready for a soft touchdown, which may be the first ever by a private company on the lunar surface. Hakuto will lift off atop a SpaceX Falcon 9 rocket from Florida's Cape Canaveral Space Force Station, and arrive at the moon no earlier than April 2023. Following landing, Hakuto will deploy a small United Arab Emirates rover, called Rashid. The four-wheeled rover will study the moon for 14 Earth days using a high-resolution camera, a thermal imager, a microscopic imager and a probe designed to examine electrical charges on the lunar surface. Takeshi Hakamada, founder and CEO of iSpace, said in a statement, "Our first mission will lay the groundwork for unleashing the moon's potential and transforming it into a robust and vibrant economic system." NASA's Orion spacecraft has spotted the destination of its Artemis 1 test flight, the moon, and captured a stunning video to mark the moment. In a video released Friday, the half-lit moon is visible in the distance with the Orion spacecraft in the foreground, complete with NASA's worm logo, as seen from a camera on the tip of one of the capsule's 4 solar wings. At the time, Orion was about halfway to the moon, NASA said in a statement. On the third day of the Artemis I mission, Orion maneuvered its solar arrays and captured the moon with a camera mounted on the end of the array. A SpaceX Dragon launching soon to the International Space Station is the last cargo version of the spacecraft the company expects to build, with one more crewed spacecraft under construction. The launch will be the first flight of this spacecraft, designated C-211, the third cargo version of the Dragon 2 spacecraft built by SpaceX. Since starting its commercial resupply services 2 contract with the CRS-21 mission in late 2020, SpaceX has been alternating between 2 other cargo Dragon spacecraft, designated C-208 and C-209. In addition to the 3 cargo Dragon spacecraft, SpaceX has 4 Crew Dragon spacecraft, and Sarah Walker, director of Dragon Mission Management, revealed SpaceX plans to build a 5th and likely final Crew Dragon. And it looks like the James Webb Space Telescope has finally gained some favorable acknowledgement from U.S. Congress. The House Subcommittee on Space and Aeronautics held a hearing to review the exciting first science results from NASA's James Webb Space Telescope. During the hearing, representatives celebrated the exceptional success of this huge, government-sponsored project, a much-needed moment of levity and awe in the otherwise tumultuous state of American politics. NASA's new telescope launched last Christmas, after decades of preparation and anticipation, and began collecting data in July. Up until then it had been the subject of much political criticism for delays and significant budget overruns, which almost saw the mission shut down, but all of that now seems to have been forgiven. And that's the news, Andrew.
Yes, Hallie, isn't it good that they decided to continue with that project? It's starting to reap rewards. I did see a documentary about the making of the James Webb Space Telescope, and Congress was scathing in their criticism of NASA when things started to run out of control in terms of the cost. But thankfully, they decided to go on with it. All right, we'll catch up with you at the end of the show. Now, to other astronomy and space science news, and private companies are playing a big role in space these days, in many cases with the blessing of national space agencies. Now, Japan has issued a startup the first ever license to conduct business activity on the moon, and that could be a game changer for lunar exploration. SpaceX has been rapidly ascending in the world in regard to its missions, private missions to the International Space Station and other areas. And while there's already a fairly solid market for taking satellites into space, national space agencies are keen to encourage companies to look beyond Earth orbit. And for many, the long-term goal is to create a bustling space economy that can help to support missions that venture further into our solar system. Obviously, Mars would be the next target. Several countries have passed laws that allow firms to extract and use space resources in the hope that this will provide a business case for more adventurous private missions. And now Japan has issued a license under its 2021 Space Resources Act that will allow Tokyo-based startup iSpace to collect and sell a small amount of lunar soil to NASA under a pre-agreed contract. If iSpace transfers ownership of lunar resources to NASA in accordance with its plan, it'll be the first case in the world of commercial transactions of space resources on the moon by a private operator, according to Sanae Tanaki, Japan's Minister of State for Space Policy. He also went on to say this will be a groundbreaking first step towards the establishment of commercial space exploration by private operators. And this is probably just the very beginning of what will become a significant development in space business and a space economy in the years to come. Now, let's talk about dark matter, if we can unravel it. Dense gas clouds across the universe absorb light from distant quasars, according to a new report, producing absorption lines in the quasar spectra. And a new study shows that the larger than predicted widths of these lines from nearby gas clouds could result from a form of dark matter called dark photons. Now, these particles could heat the clouds, leading to a widening of the absorption lines. Other explanations of the broadening, based on more conventional heating sources, have been proposed. But if the dark photon mechanism is at work, it might also cause heating in low-density clouds from earlier epochs of the universe. And researchers are already planning to test that prediction. Now, when viewing the spectrum from a distant quasar, astronomers often observe absorption lines coming from the intervening clouds of gas. The most prominent absorption line is the Lyman alpha line of hydrogen. Now, some quasar spectra have a forest of Lyman alpha lines, with each coming from a cloud at a different distance from our galaxy. And by examining the widths, depths, and other details of the line shapes, researchers can extract information about the density, the temperature, cloud features, and more. And that information can be compared with the results of cosmological simulations that try to reproduce the clumping of matter into galaxies and other large structures. Comparisons between forest data and simulations have generally shown good agreement, but a discrepancy appears for relatively nearby gas clouds. Observations show that these so-called low redshift clouds produce broader absorption lines than predicted in simulations. And they say this may be an indication of a particular candidate of dark matter which is called a dark proton, according to Andrea Caputo from CERN in Switzerland, who goes on to say this dark photon can inject some energy and heat up in the gas, which makes the lines a bit broader, in better agreement with the data. Could be an interesting finding and one worth looking into more, for sure.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now, understanding the solar cycle and its impact on climate and climate change is very important, more so now than ever, probably. And they've been looking into this over in Canada. The Prairies Climate Change Project is a joint venture initiative and focuses on weather and our changing climate. We all know the sun and the weather go hand in hand. Without the sun, there would be no life on Earth. But the sun is not completely consistent. It goes through cycles, sometimes with lots of activity, and at other times it's pretty docile. And right now we are in solar cycle 25, the 25th cycle since we began recording sunspot activity back in around 1755. And we're just climbing out of the sun's maximum activity towards its storm season, which is set to peak around 2025, and forecasts show this solar maximum could be more active than others seen this century. So as we close in on the peak of solar activity, what are the implications and what is the connection between the sun's cycle and climate? Well, the sun acts like a big magnet. It has its own magnetic field. That magnetic field is what drives the solar cycles, and the sun goes through active periods, quiet periods, and so does the Earth, according to John Manuel, who's a senior program scientist of solar terrestrial sciences at the Canadian Space Agency. And as the solar wind that continually comes out of the sun blows past Earth, it carries very energetic hot particles and magnetic fields which interact with Earth. And the sun's cycle is measured on a rough 11-year series of intervals and begins and ends with quiet solar activity. And at that time, the sun's magnetic field will completely flip, and the magnetic north becomes south and vice versa. The magnetic field will remain flipped until the next solar cycle maximum. Now, during that stormy season, the surface of the sun is peppered with sunspots, cooler regions that can produce what we call space weather. And that results in coronal mass ejections that can happen in any direction, including towards our planet. And a direct hit, as we've mentioned before, can have implications on electronics on Earth. Space weather can affect us in a lot of ways, but strong solar storms are the ones that they're worried about, particularly when it comes to electrical failures and GPS and communications. But what about climate? Well, that's the million-dollar question, and one that's very tricky to answer. But Manuel says, when it comes to climate and space weather, there are some things we know, but many things we don't. And with climate change, the scientific community agree that greenhouse gases are the cause of climate change. But according to NASA, the solar cycle and its associated short-term change in irradiance, or the amount of light energy, cannot be the main force driving changes in Earth's climate that we are currently seeing. So the sun is only reacting to what we are doing to the Earth, not causing what is happening on Earth. I think that's what they're saying. Finding that connection, though, is a focus of a newly funded satellite mission called Radicals out of the University of Alberta. So although the solar cycle is not to blame for the changes we're seeing, it does have its place in the overall climate puzzle. Still a lot of questions to be answered there. And finally, there was a project launched a few years ago. It was crowdfunded. It was called Light Sail 2, and it sent a spacecraft into space to basically test the concept of light sails. Well, the Light Sail 2 spacecraft has ended its mission. The Planetary Society's crowd-funded solar sailing craft re-entered Earth's atmosphere last week after nearly 3.5 years in orbit, more than 3 times longer than it was designed to survive. The light sail team has received no communications from the spacecraft since that fateful day last week, the 17th of November, leading them to conclude that the shoebox-sized craft has finally given up after completing 18,000 orbits and travelling about 5 million miles or 8 million kilometres around the planet. It's quite an achievement, and a lot of data has come back. And while light lacks mass, its individual particles, photons, carry momentum, which can be transferred to a reflective surface to give a tiny amount of push. And that's what they were testing with Light Sail 2. And it's shown that solar sailing is an effective and viable propulsion method for small spacecraft, including tiny satellites known as CubeSats. So it looks like the mission was a wonderful success. That's it for this particular episode. If you want to chase up those stories and more, go to our brand new URL, astronomydaily.io. It'll take you straight to the page where all these stories are published. Those and many, many more. And while you're there, you can subscribe to the newsletter. Don't forget to leave your reviews of Astronomy Daily on your favourite podcasting platform. And while you're online, whip over to spacenuts.io and catch the latest edition of Space Nuts, the podcast, with Professor Fred Watson, my good friend, astronomer at large. Anything before we wrap it all up, Hallie?
Yes. Hello, Andrew.
It's the end of the show. You're supposed to say goodbye.
I know, but it's World Hello Day, so I'm saying hello again and thought it might be nice for people to do the same if they want to acknowledge others.
Oh, that's nice. Well, hello to you too. And Hallie?
Yes.
Bye-bye.
Bye.
I think we're sounding a bit like a Beatles song. Until next time, this is Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.